Welcome students. In last class we have discussed the reflection on the basis of wave theory. In today's class we will discuss refraction on the basis of wave theory. So in this topic the question states, derive the laws of refraction of light on the basis of Huygens wave theory. Fine. Now consider your plane wavefront AB. This plane wavefront AB is incident or is moving towards the plane surface XY. Now your plane surface XY is separating two medium 1 and medium 2. Now your medium 1 is a rare medium, whereas medium 2 is a dense medium. In medium 1, the velocity of the light will be v1, and in medium 2, the velocity of the light will be v2. Fine. But note that the velocity of light in the medium 2, which is your denser medium, will always be greater than the velocity of light in medium 1, which is in rare medium. Fine. On the base of this assumption, we will start our refraction on the basis of wave theory. Now, our wavefront AB strikes the surface XY at point A first. Fine. And then successively it will strike to the point C. Now according to the Huygens principle, each point on the surface AC will act as a source for your secondary wavefront. Now from each source, your secondary wavelet will start growing. It will go somewhat like this. Fine. From each wavefront. From this source, this is the wave. From this source, this one. From this source, you have this one. And from this one, it will propagate something like this. Fine. And the tangent of this wave gives me the secondary wavefront. Okay. Now, let the disturbance, take time t to travel from B to C. The time taken for the light or your disturbance to cover this distance is t. If it takes t times, and we know the velocity of light in medium 1 is v1, therefore the distance can be denoted by the product of velocity and time, which is v1t. So this distance BC equals to v1t. Fine. Now during the time when your wave is moving in this direction from point B, so as the wave from the point A, which has already undergone refraction, will move in this point, isn't it? They will move simultaneously. Now during the time when the disturbance reaches from B to C, the secondary wavelet, this will be your secondary wavelet. This secondary wavelet will also spread from A to your point D. Now the distance covered by this one, or the time taken to cover this distance, and the time taken to cover this distance will be equal. Fine. Now since they cover the distance at equal time, which is t, and what is the velocity in medium 2? It is v2. So the distance will be the product of the velocity and time, which is v2t. Therefore, this distance equals to v2t. Fine. So, in this manner, a new wavefront will be formed. This new wavefront is known as your refracted wavefront. Fine. So if you have any confusion or any query regarding this topic, you can ask me. I will re-explain it to you again. Fine. Okay. Now, in this case, if this is the ray, so this will be my angle of incidence. Okay. If this is the angle of incidence, I can show this angle also as I. Fine. Now, this is the refracted wavefront. This is your normal. So this angle will be R. If this angle is R, I can also show that this angle will be R. Fine. Okay, if you have confusion with this part, look here very carefully. First, let us consider this triangle. Okay, let us say ABD. Consider, or let us say APD. Consider this red triangle. In this red triangle, this angle I have said it is R. Now this angle will be how much? This is your wavefront, this is your ray. Ray and wavefront are always at 90 degree. Fine. If this is 90 degree, how much will be this angle? This angle will be 180 degree minus 90 minus R. From where I got this 180 degree? This is the sum of all the angles of the triangle. If I send the other two angles, therefore I will get this angle. So this angle will be 90 minus R. Fine. So this red one is your 90 minus R. Any confusion up till here? No. Now consider this triangle, the blue triangle. In this blue triangle, this angle is how much? 90 minus R. From the previous case we have shown. And this angle, what will be this angle? This is your normal. It will be perpendicular to the surface. So this angle should be 90 degree. If this angle is 90 degree, what will be this angle? The sum of these and these angles should be again 180 degree. Fine. So 180 degree equals to 90 minus R plus your 90 degree plus this angle, let us say theta. Fine. 90 plus 90, 180. So this one gets cancelled. So I have 0. Minus R will go there. Therefore I have theta equals to. Okay, so I have said this angle will be my angle of refraction R. So this angle is also equals to R. Fine. No confusion up till now. This angle is how much? I. If this angle is I, this angle will also be equals to I. Now why is it so? Look here very carefully. Okay. This is the ray. This is wavefront. What is the angle between the ray and the wavefront? 90 degree. If this is 90 degree and this is I, what will be this angle? This angle will be 90 minus I. Any confusion with this one? No. Right? Now consider this red angle. Fine. Now in this red angle, this is the wavefront. This angle is how much? 90 minus I. And this too will be at an angle of how much? 90 degree. So what will be this angle? This angle will be the total angle minus this angle. What is the total angle? 90 degree. What is this part of the angle? It is minus 90. Minus minus becomes plus. So 90 and 90 gets cancelled. So this angle becomes I. So I've showed I equals to I. Fine. Fine. So in next class we will see how we will use this theories to prove the first and the second law of refraction. So if you have any confusion up till now, you can ask me. I will re-explain it to you again. So that's it for today's class. Thank you.